So how can I use the remainder theorem to solve this? Use synthetic division. So what's going to go on the outside? -2. And then on the inside, what am I going to put? 0 and 9, because I'm missing that x term, so I have to put a 0x there. So make sure all of your variables are represented. So we drop down the 4, multiply, add, this would be -24, multiply 48, add 53, multiply -106, add -106. Yep. Multiply 212 and then add 221. So f of -2 would be what? 221. Whatever our remainder is, that would be our answer. Number 2, we're doing the same thing, so I'm just going to skip it so we have time to get through all of them, but the answers are on campus. So next I want to take a look at number 4. We have to use the rational root theorem to find the real roots. What does roots mean? The zeros. So roots, zeros, solutions, all mean the same thing. So how do I find the roots? So I want to find the factors of the first over factors of the last, or factors of the last over factors of the first. So P over Q, which is last over first. Before I find last over first, I'm missing that constant term here. So what could I do to start? I can factor out an x. So I'm going to take out an x from everything. So then I'm left with x to the 4th power plus 6x cubed minus 9x squared minus 44x minus 30. So now I have that constant term 30. So what are factors of 30? 30, 5 and 6, 2, 15, 3 and 10. I think that's all of them. And then factors of our first, our leading coefficient is just 1, so that would just be plus or minus 1. So what can I try first? So let's try 3. So inside the box, I have 1, 6, -9, -44, and -30. Drop down the 1, multiply, add, multiply, add, multiply. 18 times 3 would be 54. Add, we get 10, multiply, positive 30, and add, we get 0. Yay, so 3 works. So one of our solutions is x equals 3. So I started with x to the 4th power. So that means my answer here is going to be x to the 3rd power plus 9x squared plus 18x plus 10. So can I factor this yet? No, I need to do P over Q one more time. But now I can use factors of 10. So my last is now 1, 2, 5, and 10. So plus or minus. And then over plus or minus 1. So what should we try next? -1. So inside my box, I'm going to put all the new coefficients that I have here. So 1, 9, 18, and 10. Drop down the 1, multiply, add. This would be 8, multiply, -8, add, 10, multiply, -10, add. We get 0. Yay, so -1 works. So I'm going to add that to my list of roots up here. Now, since this started with an x cubed, my answer now is going to start with an x squared. So x squared plus 8x plus 10. What can I do once I have a quadratic, just an x squared? I can factor it. So let's see, do I have 2 factors of 10 that add to 8? No. What do I do if I can't factor it? Quadratic. So my quadratic formula is negative b plus or minus the square root of b squared minus 4ac over 2a. So a is 1, b is 8, and c is 10. So I'm going to plug everything in. Negative 8 plus or minus the square root of b squared would be 64. Minus 4 times 1 times 10, which would be negative 40. Over 2 times 1, which is just 2. So now I have negative 8 plus or minus 64 minus 40 would be 24 over 2. What can I do next? I can simplify my square root. So what are 2 factors of 24? 6 and 4. 2 factors of 6? 3 and 2. And then 2 factors of 4 would be 2 and 2. So when we simplify our square root, we circle pairs. So pairs of 2 of a kind. So 2 would come outside. And then whatever doesn't get circled stays on the inside. So 3 times 2, which would be 6. So I have negative 8 plus or minus 2 square root 6 over 2.
If we have something like that, like, could we just, for example, like split up the 4 into 2 and 2, because we already know that that's a pair and the other one's just going to have to go on the inside?
Yeah.
Maybe just 6 on the inside.
And can I simplify this anymore?
Divided by 2.
All 3 whole numbers here are divisible by 2. So this would be negative 4 plus or minus square root 6. Is this a real 0? Yeah, because it doesn't have an I in it, so it would be a real 0. So I'm going to add that to my list. So negative 4 plus or minus square root 6. So that gives us 2 more answers there. However, we started with x to the 5th power. So that means I need 5 zeros. Right now I only have 4. I have 3, negative 1, and plus or minus, well, negative 4 plus or minus square root 6. The x I took out in the beginning to find the roots or the zeros or the solutions, we set this equal to 0. So since I took out an x, that is x is equal to 0. So 0 gets added to my list also. So these are my 5 roots. This question asks for the real roots. So if you had an imaginary answer, you wouldn't list it. But on the test, be careful. It may ask for the real roots or all the roots. So if it asks for all of them, then you would list imaginary ones too, if you had imaginary. So you'd pretty much solve the same way. If it asks for all the roots, even if there's an I in your answer, you still include it in your answer. So because this doesn't factor, we have to use quadratic. All right, next one, let's look at 6. So here I just have to perform the operations and simplify. What do I need to do first for number 6? Perfect. I got to square this. I got to do my exponent first. So this is 9 minus 4i times 9 minus 4i. So you cannot just distribute the squared. Write it twice and FOIL it out. So when we FOIL this, we get 81 minus 36i minus 36i plus 16i squared. What can I do next? The I squared turns into -1, so that makes this a -16. And then what? Combine like terms. So I have 81 minus 16, which would be 65. And then -36i minus 36i would be -72i. And then I still have the rest of the problem here, which I'm going to write down below. So plus 17i minus 19 minus 5. What can I do next? Distribute the negative, but I could also just do 19 minus 5, right? Because those are like terms inside the parentheses. But we could distribute the negative. So minus 19 plus 5, which would make this a -14. And then what can I do? Combine like terms. So 65 minus 14 would be 51. And -72i plus 17i would be what? -55i. Awesome. All right, so looking at number 7. So here we want to get the imaginary part out of the denominator. We want to make that a real number in our denominator. The first thing I would suggest to do is to put the denominator in standard form. So that would be -2 plus 10i. So I just rewrote the denominator. Now, what do I have to multiply here to get the I from out of the denominator? Perfect. The conjugate. So -2 minus 10i to the top and the bottom. So -2 minus 10i. So the same thing gets multiplied on the top and on the bottom. Now let's multiply out the bottom first. What can I do here? A squared plus b squared. So the a squared plus b squared only works when it's in standard form. That's why we put it in standard form first. So our a would be -2, so -2 squared, plus b is always the number that's in front of the I, so 10 squared.
Why'd you put 2? Oh, you multiplied.
So here this would be 4 plus 100, so we got 104 in the bottom. So now let's look at the top. How do I multiply the top? I have to FOIL. So multiply the first, we get 16, the outsides plus 80i, the insides would be minus 2i, and then the last ones would be minus 10i squared. What can I do next? Combine like terms, but before I do that, what do I want to do? Change the I squared to be a -1, which makes this a positive. So it just changes the sign of that number. So I'm going to combine 10 and 16, that becomes 26. And then I combine the i's together, so this would be plus 78i. And then our denominator was 104. Can I simplify this? What goes into 26, 78, and 104? Even better. Even better. 26. So 26 goes into all of these. So this would be 1 plus 3i over 4. All right, let's look at number 8. So here it says to solve. What should I do first to solve? Add the 7x squared to the other side. So I have 7x squared minus 6x plus 2 equals 0.
What was the
4. What can I do next? multiply the first and the last. So 7 times 2 would be 14. Do I have two factors of 14 that add to negative 6? No. So what do I do if it doesn't factor? Quadratic formula. So my quadratic formula is negative b plus or minus the square root of b squared minus 4ac over 2a. So 7 is a, negative 6 is b, and 2 is c. So negative 6 would be positive 6 plus or minus the square root of negative 6 squared is positive 36 minus 4 times 7 times 2 over 2 times 7. So inside my square root, when I simplify, 4 times 2 would be 8, and 8 times 7 is 56. So 36 minus 56 would be negative 20. So I have 6 plus or minus the square root of negative 20 over 14. What should I do next? So I'm going to simplify my square root negative 20. The negative comes out and turns into an I. What are two factors of 20? 5 and 4, or 2 and 10. And then we have 2 and 5. So I have a pair of 2's. So what else comes to the outside? So 2i square root 5. So this would be 6 plus or minus 2i square root 5 over 14. Can I simplify this anymore? How? Everything's divisible by 2. So 3 plus or minus I square root 5 over 7. And that would be our answer. All right, number 9. We have to identify all the following. So let's start with our vertex. How do I find the vertex? Negative b over 2a. So make sure your equation is in standard form, and then we have a, b, and c. So I have negative 2 over 2 times 4, which this simplifies to negative 1/4. So that gives me my x in my vertex, the first number, negative 1 over 4. On the quiz, for the most part, everybody got that, but when it came to plugging it in, that's where it all went wrong. So to find the y, the second part of our vertex, we plug in negative 1/4. So be very careful when plugging it in and evaluating. So I have 4 times negative 1/4 squared plus 2 times negative 1/4 plus 1. When I square negative 1/4, make sure you square the top and the bottom. So what is 1/4, negative 1/4 squared? 1/16. Positive. Any negative number squared turns positive. And then I have 2 times negative 1/4, which would be negative 2/4 plus 1. Bless you. So then when I multiply 4 times 1 over 16, that would be 4 over 16, which simplifies to 1/4. So I have 1/4 minus 2/4, and I'm going to change 1 to be 4 over 4. So this was 4 over 16, and I simplified the fraction because they both divide by 4, so 1/4. So you need all your denominators to be the same, and then we just combine the numerators. So 1 minus 2 plus 4 would be 3, so 3/4. So my y is 3/4. All right, next, how do I find the axis of symmetry? It's the x in the vertex, but axis of symmetry is a line, so it has to be x equals the x in the vertex. So x equals -1/4. What is my domain always for a quadratic function? -infinity to +infinity. Domain will always be -infinity to +infinity. Now to find the range or max or min, it depends on which way our graph opens. So is my graph going to open up or open down? How do we know that it opens up? The leading coefficient is positive, so it opens up. So for my range, where would my range start? 3/4. It's always the y value. So it starts at 3/4 with a bracket, because 3/4 is included, and then it goes up to infinity. So 3/4 to infinity. Now, is my vertex at the maximum or minimum? It's the minimum at y equals 3/4. Same value as the y on your vertex. So make sure you identify if it's a max or min, and then it's the y value. All right, next let's find our x-intercept. How can I find the x-intercept? Factor it. So I'm going to plug in 0 for y and factor it. So 0 is equal to 4x squared plus 2x plus 1. How would I factor this? Quadratic, but let's see if it actually factors. So we would multiply the first times the last and get 4. Do we have two factors of 4 that add to 2? Nope. So then we have to use the quadratic. So negative b would be -2 plus or minus the square root of b squared, which would be 4 minus 4ac over 2 times a. So inside my square root, I have 4 minus 16, which would be -12. Yes. What happens when I get a negative in the square root? It's not an x-intercept. So do I have an x-intercept here? Nope. So no x-intercept because this is not real. How do I find the y-intercept? It's always the last number of your equation. So it's always your c. Or we could plug in 0 into all the x's, which you'll get c. So here our y-intercept is 1. We have to put it as a coordinate point. So we plugged in 0 for x and got 1. So it'd be 0, 1. So it's always going to be your c. And then lastly, let's put it in vertex form. So our vertex formula is y equals a times x minus h squared plus k. So I have y equals, what's my a? 4. It's always what's in front of the x squared. That's your a. That's like the easiest part to find. So 4 times x, what's our h? -1/4. So our vertex has the h and k. So -1/4 would become +1/4 because we always change the sign of the h. We do not change the sign of the k. So +3/4. All right, and just for fun, let's graph it. just in case you have to graph on the test. So I start with my vertex. I'm going to put a point at negative 1/4, 3/4, so about there. What's another point on my graph that I already have? The y-intercept. So I have a y-intercept at 0, 1, so that's my second point. And then I can just put the third point on the other side of the axis of symmetry here. So my parabola opens up. So my graph looks like that. All right, let's look at number 10. All right, first for number 10, let's find the end behaviors. Which term am I going to look at to determine my end behavior? Negative 3x to the 5th. So I'm looking at the degree. Is it even or odd? Odd, which means that they go in the same direction or opposite? Opposite directions. Now my leading coefficient is negative. So what does that mean about my right arrow? Right arrow is going to go down, and since they go in opposite directions, the left one goes up. So whether it's positive or negative, that always determines the right arrow. So now looking at my arrows, the left one is going up, so I'm going to say rises left and falls right. I would always say draw the arrows first and then just look at them. Make sure you know the difference between right and left. Some people on the quiz drew the arrows correctly but wrote the wrong direction. So just be careful. All right, next, let's find the zeros. How can I find the zeros? I need to factor it. I can take out my greatest common factor, so I'm going to take out a negative 3x cubed. So divide both of these by negative 3x cubed. So then I'd be left with x squared minus 9. Can this be factored anymore? What's going to go in there? Awesome. X plus 3, x minus 3. Since it's the difference of squares, we just break it down to x plus 3, x minus 3. And then we have a negative 3x cubed on the outside. So then from here, we just set each one of these equal to 0. So negative 3x cubed equals 0. X plus 3 equals 0. And x minus 3 equals 0. So since I have an x cubed equals 0, I have 3 x's here that equal 0. For my next equation, subtract 3 on both sides, so x is equal to negative 3. And then for the other one, add 3 to both sides, so x is equal to positive 3. So there are my 5 zeros. Because x cubed was equal to 0, so I have 3 x's here that are 0. So you don't have to list the repeats 3 times, but it'll help you with your multiplicity. So if you don't put it 3 times, make sure you say I have a multiplicity of 3 at 0, because I have 3 zeros. So if you don't list the repeats here, make sure that you're telling me that you know that there's 3 zeros. And then I have a multiplicity of 1 at negative 3 and a multiplicity of 1 at 3.
Just to rewrite it, or can you put multiplicity of 1 at negative 3 from 3?
That's fine. So for the zeros, you want to list it as x equals. All right, now the action at the x-axis. This question threw a lot of people off on the quiz. But if our multiplicity is odd, what's our action? It goes through. So it goes through at 0, -3, and 3. Or you could say it goes through at all the x's because 3 is odd, 1 is odd, and 1 is odd. What if my multiplicity was even? Then it would touch and turn. Yeah, it falls right. After I just said, be careful. Yes.
So if there was a multiplicity of 2, like 3 was 2 times, so you know, like it goes through at like 0 and -3 and then,
Yeah, so if you had different types of multiplicity, if you had even and odd, make sure you say where it goes through and where it touches and turns. All right, and then last, let's graph it. So I'm going to put my graph here. So I'm going to put my zeros. So I have a 0 at 0, -3, and +3. And then next I want to put my end behavior, so the arrows. So out of the left 0, I'm going to go up. Out of the right 0, I'm going to go down. And then through all of our points on the x-axis, we go through them. So I cross the graph, and cross the graph. So my graph looks like this.